Here's problem 25.12. Identical 4 microcoulomb charges are placed on the y-axis at y equal plus or minus 4 meters. Point A is on the x-axis at x equal 3 meters. Determine the electric potential at point A relative to 0 at the origin. Alright, so let's see what we got here. Here's x and y. Here's plus 4 meters on the y-axis, minus 4 meters on the y-axis. We have two charges, identical charges, both of them positive. Let's use blue for that. And they're both 4 microcoulombs. So Q1 is 4 microcoulombs. Q2 is 4 microcoulombs. And point A is 3 meters on the x-axis. And we want to find the potential of point A relative to 0 at the origin. What do we mean by that? Well, that would mean if we were comparing A to B, we want to find out how high above, in terms of potential, A is above B. In other words, whatever the potentials are, we're going to set B equal to 0 and A relative to that. So we really need to find the potential difference of A versus B. That's what we want in order to make it relative to 0 at point B. So potential at A is going to equal K Q1 over R1 plus K Q2 over R2. And this is going to be equal to 9 times 10 to the 9 times Q1 is 4 microcoulombs. And we are at position A. What is our distance? Well, we have ourselves a 3, 4, 5 triangle. So that distance is 5 meters there and 5 meters there. So this is going to be 5 here, plus another 4 microcoulombs, also 5 meters away from point A. And what is that equal to? 14,400 volts. Okay, so that's potential at A. Let's find the potential at B. Do the same thing. It's going to be K Q1 over R1 plus K Q2 over R2. Both scalar values. In this case, both of them positive. So we have 9 times 10 to the 9. Q1 is 4 microcoulombs. And at point B is 4 meters away from the charge. Same thing for the other charge. Also 4 meters away. So we're just looking for the pure distance away from that charge. And this is equal to 18,000 volts. So that's potential at B. We want to find the potential at A relative to B. So really our potential at A relative to B is going to equal the potential at A minus the potential at B. And that's going to be 14,400 minus 18,000, which would be a negative 3,600 volts. In other words, if we make point B the origin 0, then relative to that, A is 3,600 volts less than that. And so that's why the potential at A relative to 0 at the origin is a negative 3,600 volts.